So we will discuss today the important topics again. It will be asked for 5 marks, sometimes it will be for 8 marks. The topics what we are going to discuss today is first one, definition of property. Definition of property. Okay. In thermodynamics, we will also call it as thermodynamic properties. Thermodynamic property. Second one, examples. Examples of property. You might have studied in some other subjects also. Here in thermodynamics related, how many properties are there, which are those, all those we'll discuss in examples. And the third topic is types of property or classification of property with examples. These are the three topics we'll cover in today class. So first one is property. Before defining the definition of the property, I will give the examples so that you'll understand better. First, thermodynamic property, the basic three thermodynamic properties are pressure, volume, temperature. And these are the basic properties we'll be using. So using these three properties, some other properties will generate, that is internal energy U. You have to keep in mind internal energy U, enthalpy H, and entropy S. Okay. So these are derived properties, we can say, derived from fundamental properties. Okay, pressure, volume, temperature. So there are some other properties is also there in thermodynamics. Okay, these are the standard 6 properties, you remember. Now look, after seeing these 6 properties, now what is the definition of property? Okay, to understand the definition of the property, let me ask one simple question. Assume that this is a person, man. Okay, on what basis you will say this person is good or bad? Is a good person or bad person? Based on his behavior or based on his characteristics. If his characteristics are good, then we can judge, oh, he's a good person, he's a very good gentleman. If his characters, behaviors are not good or not expected as we like, so you can say it is not a good bad person, it is a bad person. So based on characteristics. So based on characteristics like some parameters, it will be visible or invisible. So based on these characteristics, we are judging. We will judge that whether this person is a good person or a good gentleman or not. Similarly, to define any system, okay, we require some properties. So properties are characteristics of the system. Characteristics of the system or behavior of the system we can use. So any how you can write in the exam is the parameters. I will write here the definition. Okay, the parameters which are used to determine, which are used to specify the characteristics of the system, those parameters we can call it as property. Okay, property, it is a function. It is a function which determines the characteristics or behavior of the system. So pressure is one property, volume is property, temperature is property. So these are basic formulas, basic properties. Using these basic properties, we'll derive internal energy U, H is enthalpy, S is entropy. Okay, sometimes mass also will consider as a property. So using these three properties, all equations will be written, all equations will be derived. For example, ideal gas equation, PV is equal to mRT. Here temperature is property, pressure is property, volume is property, mass is also property, this gas constant is also property. Okay, so R is gas constant, we can consider it is also a property. So there are many properties are there in the thermodynamic science. but the standards are these three: pressure, volume, and temperature. So this is examples. What is the definition of property? Property, it is a function. Okay, it is a function which defines or which which determines the characteristics of the system is called as property. Or you can use other word, a property or the parameter, okay, which determines the characteristics of the system. How much is the pressure of the system? The pressure is one property, that is a parameter. So based on that parameter, we are saying that this is a pressure, P is equal to 1 bar. Based on other parameter means maybe other parameter, temperature of the system is 10 degrees Celsius. Volume of the system is 1 meter cube. So similarly, other properties are also coming to the picture: internal energy, enthalpy, and entropy. Now coming back to the third and important, for exam point of view here, types of property. There are two types of properties coming to the picture. One is intensive property, intensive property. Another one is extensive property, extensive property. So what is the difference between these two is both are property. Okay. So out of this 1, 2, 3, 4, 5, 6, these are the 6 properties I have explained here. So out of 6, some properties belongs to intensive. Out of 6 properties, some properties will belongs to extensive property. Now we'll understand what is intensive and extensive. So intensive properties are the properties which are independent on mass of the system. Okay, the properties which are independent means not dependent. Independent, or you can use what do not, does not depend, not dependent on mass of the system. I will give some examples, do not worry. So any property which is independent on the mass of the system, that property is called as intensive property. I will give some one hint how to remember is IN, independent. So I stands for independent. Just you remember like this, because 70% of the students in the exam they will get confused. Okay, instead of writing extensive, they will write intensive definition. In intensive definition, they will write extensive. So do not get confused here. It is very easy. I stands for intensive. I means independent on mass of the system. Then extensive is a property which is dependent on mass of the dependent on mass of the system. A property which is dependent on mass of the system is called extensive. A property which is independent on mass of the system is called intensive property. And dear students, now you remember one note. Okay, I will give an example later. Do not worry. Okay, what is that note is a ratio of two extensive property will become an intensive property. I will give example. Ratio of two extensive or ratio of two extensive property. For example, X, assume X is an extensive property. What is X? X is dependence on mass because it is extensive. Mass is there in the numerator. Similarly, Y is also extensive property. Y is also dependent on mass. So both numerator and denominator, both parameters are dependent on mass. So get cancelled. Then the answer, the final solution will become intensive because both get cancelled. Mass in the numerator and mass in the denominator, both terms get cancelled. Then it will become an intensive property. Have understood? Have understood this note?
Yes, sir.
Okay. So this is important. You remember because in exams they will get confused, and they give some examples where it looks like extensive, but it is intensive. Okay, because it will be ratio of two extensive property. And one more point. One more, the second note, what you need to remember here is, that is also important. When I will write, this is point number 1, point number 2. Extensive property, divided by mass, again it will become intensive property. Keep in mind. Why it is extensive property depends on mass. Mass is there in the numerator, and you are dividing it by mass. Externally, you are dividing in the equation. You are dividing by mass. So mass get cancelled. Again, it becomes intensive property. Okay, and remember third point: all specific properties, all specific properties are intensive property. When I give the example, you can judge easily. Remember all specific properties. Specific properties means any property which starts with word specific. For example, specific internal energy, specific enthalpy, specific volume, okay, specific entropy. Understood? All these properties, any property which starts with the word specific, then assume it is an intensive property. Okay, so next, these are the three properties are there. These are the three notes, you remember. Now I will give the examples, then I will tell you how to classify whether it is intensive and extensive. The first, I will take it as example. First example, I will take it as temperature. Now dear students, you tell me whether temperature of the system is nothing but body. You remember temperature of a body, whether this depends on mass of the body or independent on mass of the body. Whether temperature depends on mass?
The temperature of depends on mass, sir.
How it is depends on mass? For example, this is a classroom. Here is a classroom. In this classroom, there are 4 students are sitting. 1, 2, 3,
Hello.
4. Yes. There is a classroom. There are 4 students. Student 1 number, student 2, student 3, student 4. Okay. Here, in these 4 students, assume the classroom is a system. Classroom is a system. All 4 students are there in the same classroom, then temperature of the system remains same. It will not change with respect to number of students. For one student, the same temperature, for his also same temperature, for his third student, for 4 students. So temperature is same. So temperature is an independent property, independent on mass of the system. So it is intensive. Intensive property. Remember. Okay. Intensive property, that is temperature. Second one. Second is color. Color. You take 1 glass of red solution, red color. You take 1 tank of water with red color. You are using red color. I am asking you identify the color of glass and tank. So color is whether it is dependent on mass. Based on the mass, will you judge whether this is a white color, this is black color, this is a red color, this is green color, like that? Color whether it is dependent on mass or not dependent on mass, that is independent on mass. Independent on mass. So it is independent on mass. So it is also intensive property. For example, a boy, small kid is there, a baby is there. It is white color, and one more big person of 40 years old, 40 years old man. So based on the color you are deciding, your 40 years old is extensive, the small baby is intensive. No, not like that. Irrespective of the mass, the color is always a intensive property. It is not dependent on Mass. For example, I will give one more example for this temperature, my dear students. You may understand better. How much will be the boiling point of water? That is 100 degrees Celsius. If you take one glass of water, if I ask you how much is the boiling point of water, you will say that 100 degrees Celsius. If I take one tank of water and I will ask you how much is the boiling point of water, you say 100 degrees Celsius. So the water will boil always at 100 degrees Celsius, irrespective of it is mass. Maybe amount of heat required is more for the tank. The tank water may require more heat than the glass, but both water in the tank and as well as the glass will always boil at 100 degrees Celsius. So temperature is independent on mass. So it is a intensive property. Color is also intensive property. So one more point is boiling point. Boiling point is also a intensive property. Intensive. And dear students, could you tell me any other properties which are intensive or extensive? You tell me, okay, this is a property intensive, this is a property which is extensive. Okay, mass, for example, mass. Mass is intensive or extensive?
Extensive, sir.
Extensive, because anyway the name indicates mass, so it is extensive. It depends on mass. Depends on mass, so it is extensive. Okay, volume. Volume is dependent on mass or independent on mass? Volume.
Dependent on mass, sir. Volume.
Dependent on mass. It is also dependent on mass, correct? So it is extensive. Extensive. Okay, I will give an example. You tell me whether it is dependent on mass or independent on mass. So melting point. What is melting point temperature? The
Dependent on
temperature
mass, sir.
at which the substance will melt, okay, from solid to liquid. So melting point is dependent on mass or independent on mass?
Dependent on mass.
Dependent on mass. How it is dependent on mass? For example, I will give
It
one.
need a mass to melt an object.
Okay, I will give one piece of iron. How much is the melting point of iron? Approximately some x temperature is melting of point of one piece of iron. Similarly, I will give 1 kg of iron. Iron temperature, melting point temperature will not change, no? Always, if you take 1
Yes, sir.
gram or 1 kg or 1 quintal, 1 ton, that melting point temperature of the substance will remain same. So it will not change with respect to mass. So again, it is intensive property. It does not depends on mass. It is an intensive property. For example, hardness. You tell me one more. Hardness. Hardness property of a material. Hardness is intensive or extensive? Hardness of iron, hardness of copper is this much. Okay, will the hardness will change with respect to mass, or the hardness of a material will be standard always?
Standard always.
Always standard. So it doesn't depends on mass. So it is a intensive. It does not depend on mass, because if you take 1 gram of iron and you measure the hardness, it will give the same value when you take 1 quintal of iron and measure the hardness. Hardness value will not change. Maybe it may take more load to bend, maybe more load, more force, more pressure to make it to different structure, but hardness value will be remains same. So it is a intensive, it is an intensive property. Okay, now I will ask you one question, simple question in general. Now all these are all with respect to thermodynamic point of view. Let me ask with some general. Cup of milk with sugar. Please listen my words carefully. Cup of milk with sugar.
Extensive property.
Why you are saying it is extensive?
Because a cup of milk with sugar, sugar is a mass, dependent
Yes,
on mass.
sugar is a mass. As the percentage of sugar varies, then the taste of milk also changes. So here it is a extensive. Very good, extensive property. Okay, now I will ask one more question. One more simple some questions I will be asking you. Specific volume. Specific. Note number 3 you need to remember. Any property which starts with word specific volume it belongs to which category? Extensive or intensive?
Intensity.
Intensive.
Intensive.
Intensive. Okay. So I will explain you how it will become intensive. And dear students, keep in mind this formula is very useful for higher semesters also. Here, specific and volume. There are two words. Specific is one word. Volume is another word. Volume is a extensive property. It depends on mass divided by specific means always with respect to mass. We will explain with respect to 1 kg. In the maybe in the classroom or maybe outside, some people may say specifically I am telling you do not disturb. So what does it mean? He is concentrating per kg only for one person, per kg or per person. So per person means individually he is concentrating. So it depends on mass. So mass get cancelled, it becomes intensive property. And simple, remember, any property which starts with word specific, then you call it as intensive property. Similarly, specific enthalpy. Specific enthalpy. Again, you can use a word, you can hint, you can use a hint what I have given. So this property is starting with word specific. So it will be
Intensive property.
intensive property. So in the exam, in the university, they may ask you define property and explain two types of property with examples, intensive and extensive. Or same question they may ask you in different way. They give on 10 to 12 examples. Out of 12 examples, you need to classify. Some examples will belong to intensive property and some examples will belong to extensive property. You have to make two columns and you have to write the definition and you have to classify. Okay, now I will tell you one more interesting formula. This may ask you in the interview or some viva questions. Density is an intensive or extensive? If you are becoming confused with the
Extensive,
word,
sir.
why it is extensive?
Mass.
Okay, based on formula you are telling it is extensive, but I will tell density. What is the formula? Ratio of mass by
By
volume. Volume. Mass in the numerator and volume. Mass is a extensive property. Correct? You said that mass is extensive property. Volume is also extensive property. So both get cancelled. It will become mass get
intensive.
cancelled. It become intensive. So note number 1. Note number 1. That hint I have given. If ratio of two
There are
extensive
two
property,
extensive property.
yes, ratio of
Yes, sir.
two extensive
Intensive.
property will lead to intensive property. So keep in mind such questions they may ask you in the exam. So by looking the word, you may suddenly judge that it is intensive property. So don't decide suddenly. Okay, if you take a time, write the formula. In the numerator is also mass and the denominator, if mass are there, both terms get cancelled and you make it as intensive. So it is an intensive property. Similarly, I will write one more example. It looks like same density. Okay, I will give some explanation why density is an intensive property. And dear students, now I am sitting in my home. You are sitting in your home. Okay, so temperature of the atmosphere may vary. You take one glass of water in your home, and how much is the standard density of water? 1000 kg per meter cube. Okay, and in my home on the top terrace I have a tank, big tank of maybe 500 liters. If anybody asks me what is the density of water which is available on the terrace of your tank, I should say it is 1000. is a standard value of density of water. It will not change with respect to mass. You take one glass, one cup, or one spoon of water, so density of water will be remains same. So because numerator and denominator both will change, finally we'll get answer same. For example, one glass of water, mass density of mass is maybe it is some value in the numerator, and denominator volume will change, accordingly mass will also change, and the final answer will also change. So density is a intensive property. Similarly, with respect to density, I will give one more example. Pressure. Pressure is an intensive or extensive. If you are becoming confused with word pressure, you write the formula. What is the formula for pressure? Or you tell me unit. I will write you the formula. What is the unit of pressure? Newton per
Meter.
meter square. Meter square. Newton per meter square is a pressure. Newton is a unit of what?
Force.
Force. Meter square is a unit of
Area.
area. What is the formula of force? What is Newton's law? Force is equal to m into acceleration due to gravity. So what is this m?
M into A.
What is this m? Mass. So this Newton, this property indirectly depends on mass. The numerator is mass divided by area. Area is also extensive property. I will tell you how area is extensive property, because volume is equal to area into length. Area into length. So here volume is extensive, area is also extensive, but length is intensive. Area is an extensive. Extensive is depends on mass. So mass both get cancelled in the equation. So the pressure will become again intensive property. Okay, you have to be careful in selecting or deciding whether it is intensive and extensive. First you write the formula and analyze it, then it will become easy. Okay, similarly, one more I will write, entropy. I will write only entropy, not specific entropy. Entropy is a extensive property, because denominator, there is no specific word. If it is specific, it will be intensive. If it is without specific, then it is extensive. Extensive property. Similarly, enthalpy. Enthalpy is also extensive property. Enthalpy is also extensive property. Okay. Similarly, now could you tell me the strength of your class is an intensive or extensive? Your class strength is intensive or extensive? Whether it depends on mass or not, depends on number of students or not.
Intensive. It doesn't depend on mass.
Why?
So you said like if there any ಈ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಎಷ್ಟೇ ಜನ ಇರ್ಲಿ
I am asking you strength.
ಮೇಲ್ಗಡೆ ಸ್ಲೈಡ್ ಅಲ್ಲಿ ಹೇಳಿದ್ರಿ ಸರ್ ಅದೇ
ಅದು
ಸ್ಟೂಡೆಂಟ್ಸ್ ಎಷ್ಟೇ
ಟೆಂಪರೇಚರ್,
ಜನ ಇರ್ಲಿ
ಅದು ಟೆಂಪರೇಚರ್ ಬಗ್ಗೆ ಹೇಳಿದ್ದೆ ನಾನು ಸ್ಟ್ರೆಂತ್ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ನಾನು ಸ್ಟ್ರೆಂತ್, how much is your strength in your class? In aeronautical engineering there are 45 students. On what basis I am saying 45? Because number of students are 45. Strength of a class depends on number of students. Number of students varies with respect to mass. So strength of class is extensive. Okay. See, there in the first slide I take temperature. Temperature of the classroom will not change with respect to the number of students, right? Temperature of the atmosphere for a period of time, it will be remain same. It will not change for a period of time. All these are for a period of time. Similarly, you tell me velocity of bike when it is moving on the road. Assume there is one bike. You take two bike here. Here one person is sitting on the bike. So this bike is moving with respect to some speed, some velocity. So velocity of this bike, whether it is intensive or extensive, it is moving, it is on the way. Whether velocity of bike will it change with respect to mass? It will not change because it is moving. Velocity will not change. So it is intensive. I am not using word. Some suddenly one more student has sitting here. One more student is sitting on the bike. Again, velocity decreases. In that case, it will become an extensive property. But I am using the word bike is moving with some velocity. So means only one person is riding the bike. If suddenly one more person is sitting, in that case, it will become an extensive. Okay. So on the road, one bike is moving and the velocity of the bike is intensive. It is moving with same speed. Okay. So there is no change in the mass of the vehicle. There is no change in the mass of the body of the person who was riding. Okay. So here velocity of bike is a intensive property. So any doubts in this topic?
No, sir. Sir, that you told that
Okay.
nothing, sir.
Mm-hmm.
Clear, clear.
Okay. These are the topics. So what are the topics we have discussed today? Definition of property, examples of property, types of property with examples. Okay. So we'll wind up today class and we will continue in the next, that is equilibrium. That is also important point. Parameter equilibrium. Okay. If you have any doubts, you
Sir.
can ask me.
No, no, sir.
Okay. So there you refer some question papers and there they will give different types of properties and identify whether it is intensive and extensive property. For example, surface tension. Surface tension is a extensive property. Potential energy, kinetic energy, entropy, enthalpy, volume, area, all these depends on mass or size. Mass or size. Okay. We can use word size also, mass or size. Temperature, it does not depends on size, it will remain same. Color is also does not depends on size. Okay. If it is a wall with white color, big wall with white color and small wall with small size wall color, white color, you can say oh white is a wall. Okay, it is a independent property, so independent on mass, so it is intensive property. Okay. So okay, thank you. So if you have any doubts, you can ask me in the comment section. I will respond to your answers. Okay. Thank you. Bye bye.
Thank you, sir.
Thank you.